Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to learn a problem from exercise 7.1 sixth problem. So see here what he is asking. Show that the following points form an equilateral triangle. So a small a comma 0, b minus a comma 0 and c 0 comma a root 3. So here he has given 3 points. He is asking to show that the 3 points form an equilateral triangle. So what is an equilateral triangle? So if the lengths of all the 3 sides are equal, then it is known as equilateral triangle. So the lengths of all 3 sides are equal. So see here, suppose if ABC is an equilateral triangle, so the length of AB, BC and CA are equal. So if we show the lengths of AB, BC and CA are equal, we can say that the given 3 points form an equilateral triangle. So the length of AB, it is nothing but the distance between the points A and B. So the length of BC is nothing but the distance between the points B and C. In the same way, the length of AC is nothing but the distance between the points A and C. So to find the lengths of AB, BC and CA, just we have to find the distance between AB, BC, CA. So we have to find distances using distance formula. So see here, these are the given points. Now how to find the distance between A and B, B and C and A and C. If we get all the 3 are equal, we can say the given 3 points form an equilateral triangle. So see here, how can we prove? The given points are a comma 0, b minus a comma 0 and c comma 0, c 0 comma a root 3. So now I have to find the distance using distance formula. So what is the distance formula? This is the distance formula. D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So now I have to find the distance between A and B. So the distance between A comma 0 and B minus a comma 0 is AB. So now just we have to substitute in the formula. So square root of x2 minus x1 whole square plus y2 minus y1 whole square. Let the first point be x1 comma y1 and the second point be x2 comma y2. So x2 minus x1 whole square. Here x2 is minus a, x1 is a. So minus a minus a minus a whole square plus y2 minus y1 whole square. Y2 is 0, y1 is also 0. We can get 0 minus 0 whole square. 0 minus 0 whole square. Just I am simplifying. See here what we get. So minus a is minus 2a whole square. Minus 2a whole square plus 0. So it is nothing but square root of minus 2a whole square is 4a square plus 0 is 4a square. We can get plus or minus 2a square. Since it is a distance or length, since it is the length of the side, just we have to take positive only. That is 2a units. 2a units. Square root of 4a square is equal to plus or minus 2a we get, but here we have to take only positive value since AB is the length of the side. So here we have AB is equal to 2a units. So in the same way, how to find the distance between B and C and C and A. The distance between B minus a comma 0 and C 0 comma a root 3 is BC is equal to again we have to substitute in the formula. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is the distance formula. Let it is x1 comma y1 and it is x2 comma y2. So square root of x2 minus x1 whole square. Square root of x2 minus x1 whole square. x2 is 0, x1 is minus a. So 0 minus of minus a whole square plus y2 minus y1 whole square. y2 is a root 3, y1 is 0. So that is a root 3 minus 0 whole square. So just you have to simplify now. So see here what we get. So 0 minus into minus plus 0 plus a is a whole square, that is a square, plus, so here a root 3 minus 0 is a root 3, a root 3 whole square is 3a square, we get 3a square. So that is equal to square root of a square plus 3a square is square root 4a square. Again we can get it is also 2a units. 2a units. So this is the distance between B and C. Next we have to find the distance between A and C also. So now the distance between A comma 0 and C 0 comma a root 3 is again we have to use the distance formula. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is x1 y1 and it is x2 y2. So x2 minus x1 whole square, x2 is 0, x1 is a, so 0 minus a whole square, 0 minus a whole square plus y2 minus y1 whole square. Here y2 is a root 3 minus y1 is 0. A root 3 minus 0 whole square, a root 3 minus 0 whole square. So just we have to simplify here. So 0 minus a is minus a whole square, we can get a square. So a root 3 minus 0 is a root 3. So a root 3 whole square, we can get 3a square. So here square root of a square plus 3a square, we get 4a square. So square root of 4a square is equal to 2a units. So we have all the lengths of three sides. AB is equal to, therefore AB is equal to 2a, comma BC is equal to 2a, and CA is also 2a. CA is also equal to 2a. Therefore we have AB is equal to 2a units, BC is equal to 2a units, CA is equal to 2a units. So AB equal to 2a, BC equal to CA equal to 2a. So the lengths of all the three sides are equal. Therefore we can say that the given points form an equilateral triangle. Since the lengths of all the three sides are equal, therefore we can write AB is equal to BC is equal to CA. The lengths of all the three sides are equal. The lengths of all the three sides are equal. Therefore we can say that the given 3 points form an equilateral triangle. Therefore we can say, that the given 3 points form an equilateral triangle. So like this we can find this is the 6th problem in the 7.1 exercise. Next we have to solve 7th problem. This is 7th problem from 7.1 exercise. See here what he is asking. Prove that the points minus 7 comma minus 3, 5 comma 10, 15 comma 8 and 3 comma minus 5 taken in order are the corners of a parallelogram. So here he has given 4 points. Show that the given 4 points are the corners of a parallelogram. Corners are nothing but the vertices of the parallelogram. He is asking to show them they are the vertices of the parallelogram. So let the given points be A, B, C, D. So you have to take in order he is asking. So that is very, very important. See here it is a parallelogram. So either you have to take clockwise or anti-clockwise. So I have taken A, B, C, D. You have to follow A, B, C, D. It is not the correct way. So you have to follow the circular path either clockwise or anti-clockwise. If I take A, B, next C, you have to take here only. So that is the order. So you must follow the order A, B, C, D. So this is so let it is A, B, C, D. So now A is minus 7 comma minus 3, B is 5 comma 10, C is 15 comma 8, and D is 3 comma minus 5. So now how can we show the given points are the corners of a parallelogram? So by finding the distance again. So what are the characteristics of a parallelogram? Opposite sides are parallel and equal. So here opposite sides are parallel and equal. So AB and CD are equal. In the same way AD and BC are equal. So these two are opposite sides and these two are opposite sides. So opposite sides are parallel and equal in a parallelogram. So this is the first characteristic. So in rectangle also opposite sides are parallel and equal. But how can we vary parallelogram and rectangle? Again, to check whether it is parallelogram or rectangle, we have to find the lengths of the diagonals. Here AC and BD are the two diagonals. So in the parallelogram the diagonals are not equal, but whereas in the rectangle the diagonals are equal. So here we have to show that the lengths of opposite sides are equal and the diagonals are not equal. Then we can decide that the given 4 points are the corners of a parallelogram. So for that again we have to use only one formula, distance formula. To find the length of AB, BC, CD, DA, AC and BD, just we have to use the distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. So see here, now how to find the distances, all the distances. See here now, the distance formula equal to, the distance formula D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So now I have to find the distance between A and B. So the distance between A and B, so it is denoted by AB is equal to, just we have to substitute in the formula. So let the first point be x1 and y1 and it is x2 and y2. Square root of x2 minus x1 whole square. Here x2 is 5, x1 is minus 7. So we can write x2 minus x1 whole square is 5 minus 7 whole square plus y2 minus y1 whole square. y2 is 10, y1 is minus 3. That is a 10 minus of minus 3 whole square. So now just we have to simplify. So see here what we get. 5 minus of minus 7, it is 5 plus 7 whole square. 5 plus 7 whole square plus 10 minus of minus 3, it is a 10 plus 3 whole square. So see here, 5 plus 7 is 12, 12 square is 144 plus 10 plus 3 is 13, 13 square is 169. So 12 square is 144, 13 square is 169. So 144 plus 169, just I am adding here 144 and 169. 9 plus 4 is 13, 11, 313. So square root of 313 units. So this is the length of AB. So again we have to find the length of BC. The distance between B and C is, it is denoted by BC is equal to, again just we have to substitute in the formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. Let it is x1 comma y1 and it is x2 comma y2. Square root of x2 minus x1 whole square, that is 15 minus 5 whole square. x2 is 15, x1 is 5, so 15 minus 5 whole square plus y2 minus y1 whole square. Y2 is 8, y1 is 10, so 8 minus 10 whole square, 8 minus 10 whole square. So now just we have to simplify. So see here, 15 minus 5 is 10, 10 square is 100, 10 square is 100 plus 8 minus 10 is minus 2, minus 2 whole square is plus 4. So square root of 100 plus 4 is a square root of 104 units, 104 units. So this is the distance between BC, that is the length of BC. So next, the distance between C 15 comma 8 and D 3 comma minus 5 is CD. Again just you have to substitute in the distance formula, that is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So here it is x1 y1 and it is x2 y2. So x2 minus x1 whole square, x2 is 3, x1 is 15, that is 3 minus 15 whole square, 3 minus 15 whole square plus y2 minus y1 whole square. Y2 is minus 5, y1 is 8, that is minus 5 minus 8 whole square. So just we have to simplify here, what we get. So 3 minus 15 is minus 12 whole square, minus 12 whole square plus minus 5 minus 8 is minus 13 whole square, minus 13 whole square. So see here, minus 12 whole square is minus 12 into minus 12, we can get 144. Minus 13 whole square is minus 13 into minus 13, we can get 169. So 169, again we can get a square root of 313 units. Square root of 313 units. 144 plus 169 is 313. So this is the distance between C and D. Next we have to find the distance between A and D. So now see here, the distance between D 3 comma minus 5 and A minus 7 comma minus 3 is AD is equal to, again just we have to substitute in the formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. Let it is x1 comma y1 and it is x2 comma y2. So x2 minus x1 whole square, x2 is minus 7, x1 is 3. So x2 minus x1 whole square is minus 7 minus 3 whole square plus y2 minus y1 whole square. Y2 is minus 3 minus y1 is minus 5 whole square. So now we have to simplify it. Minus 7 minus 3 is minus 10 whole square, minus 10 whole square plus minus 3 minus of minus plus 5. So here minus 3 minus into minus plus 5 whole square. So that is minus 10 whole square is minus 10 into minus 10. We get plus 100. Minus 3 plus 5 is, it is nothing but 5 minus 3. 5 minus 3 is 2. 2 square is 4. Square root of 100 plus 4 is a square root of 104 units. 104 units. So this is the distance between A and D, that is the length of AD. So now we have found all the lengths of sides AB, BC, CD and DA. So here next we have to find the lengths of the diagonals AC and BD. We have to find the distance between A and C and B and D. The distance between A minus 7 comma minus 3 and C 15 comma 8 is AC. Again just we have to substitute in the distance formula. It is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Let it is x1 comma y1 and it is x2 comma y2. So x2 minus x1 whole square. x2 is 15, x1 is minus 7. So here 15 minus of minus 7 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. So y2 is 8, y1 is minus 3, that is 8 minus of minus 3 whole square. So just you have to simplify what we get. See here 15 minus of minus 7, it becomes 15 plus 7. 15 plus 7 whole square plus 8 minus of minus 3, it becomes 8 plus 3 whole square. So just we have to simplify further. 15 plus 7 is 22. 22 square is 484. 22 square is 22 into 22. We can get 484. 8 plus 3 whole square. 8 plus 3 is 11. 11 square is 121. 121. So now we have to add how much here. See here 484 plus 121. Just we have to add 484, 121. 4 plus 1 is 5. 8 plus 2 is 10. So here 6. 605. Square root of 605 units. Square root of 605 units. This is the length of AC. So next we have to find the length of BD also. So the distance between B and D. So now we have to find the distance between BD. So the distance between B 5 comma 10 and D 3 comma minus 5 is BD. So again we have to substitute in the distance formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. So here x2 is 3, x1 is 5. So 3 minus 5 whole square plus y2 minus y1 whole square. y2 is minus 5, y1 is 10, that is minus 5 minus 10 whole square. So now I have to simplify what we get. See here 3 minus 5 is minus 2, minus 2 whole square. It is a minus 2 whole square plus minus 5 minus 10 is minus 15. Minus 15 whole square. Minus 15 whole square. So again you have to simplify it further. So minus 2 whole square is 4 plus 4 plus minus 15 whole square is 225. Minus 15 into minus 15 we can get plus 225. So square root of 4 plus 225 we can get square root of 229 units. So we have found the length of AB, BC, CD, DA and AC, BD. So now we have to check the whether the opposite lengths are equal or not. We have, see here we have, so if you observe here, so these two are the opposite, AB and CD, BC and AD. So AB and CD are equal. So that implies we have AB is equal to CD and so BC and AD are opposite sides. BC equal to square root of 104 and AD is also square root of 104. So these two also equal. BC is equal to AD. So in the same way we have to find the opposite sides are equal, whether it may be a rectangle or a parallelogram. To decide further whether it is rectangular or parallelogram, we have to check the lengths of the diagonals. If the lengths of the diagonals are not equal, then we can decide that it is a parallelogram. So therefore these two are the lengths of the parallelogram. So see here, here AC is equal to how much? The length of the first diagonal AC is equal to square root of 605 units and the length of the second diagonal BD is equal to square root of 229 units. So it is also very clear AC is not equal to BD. So AC is not equal to BD. AC is not equal to BD. So definitely it is a parallelogram. Therefore the given 4 points are the corners of a parallelogram. Therefore we can write therefore we can write the given 4 points are the corners of a parallelogram. Since the opposite sides are equal and the diagonals are not equal, hence we can decide that the given 4 points are the corners of a parallelogram. So very important, and very easy. Just we have used only one formula, distance formula. So as I said very earlier, this first exercise totally depends upon the distance formula only. Using only distance formula we have to solve all the 15 problems in the 7.1 exercise. So this is the 7th problem in this first exercise. So that's all today's class. We will meet in the next class with another problem. Thanks for watching.